So now let's take a look at the autonomous independent VI. It turns out it's very similar, if not basically identical, to the autonomous independent VI we had in the basic framework. Remember before we had this robot data global. In the basic robot main we had to write our device references into that global so that they were available in the autonomous. So let's start those same modifications we did for the basic framework autonomous mode. If we stretch this down to make a little bit more room and switch on the autonomous mode by changing this constant. Remember, if you run this, your robot is going to start moving when you switch it to autonomous mode. So either delete this code or put the robot up on blocks. Let's go to our cluster palette. Again, choose an unbundle by name. We're going to take some data out of the robot data global. If we pull this down, we're going to see a pleasant surprise. The gyro device ref, the pan servo, and the switch off time are all made available here in this robot data. And the reason for that is, if we double click to open up the global, we'll see that the global actually contains our robot data typedef. So whereas before, whenever we made a modification, whenever we added anything on the robot main, in the basic framework we had to modify the global, this time as long as we put it into the typedef, it's going to be automatically available everywhere for our teleop mode and for our autonomous mode, which is a really great advantage. So again, we can pull this down to access our gyro. We can pull this down to access our servo. And we can do whatever code we want here. The only other comment I'm going to make is related to data such as the switch off time. Just because the data type has been added to our typedef, that doesn't necessarily mean that the data values that we had in the teleop mode will be available in the autonomous mode. If we were to run this right now and we were to make our necessary modifications, I won't right now because I don't want this video to go on too long, and you can make the same modifications you saw in the previous blog entry where we did it to the basic framework. But if you were to make some modifications using the gyro and the pan servo, you'll find that the references are there, but you'll find that any other data you added is not available. Let's take a look at the reason why. This is a global variable, so we can right click on it, choose Find, all of the global references. So this is telling you everywhere that this global is being read from or written to. So we see that it's being read in the autonomous independent VI, and we can see that it's being written in the begin VI. So if we go to that instance of the global, if you didn't notice it before, you see that it's happening right here. That in the begin.vi, where we made those modifications to add the gyro and the servo, and we put them into our cluster, after making the modifications to the typedef, that data is going in parallel to the robot data output and to the robot data global. But notice here, we're not wiring anything into that switch off time. Do you remember where we added the switch off time? It was in the teleop VI. It was only in the init state here where we put that data into our cluster. Nowhere does that data get inserted into the global, which is available in the autonomous mode. And another important thing to notice is that the joystick reference is created within the teleop VI, which means it also will not be available in the autonomous mode. Now that's obviously intentional because we're not allowed to use the joysticks within the autonomous VI. It's really important to understand that any information you add to this data type in the code that you write for your teleop is not going to be available for the autonomous. And that's also true in reverse. Any information you add into that data in the autonomous mode is not going to be available for you when you switch to teleop. So that's a bit of a more advanced topic, something that we may perhaps get into in a later blog entry. But for now I just wanted to make it clear that although the data type propagates, the information itself does not. And that's something that's a little bit different between LabVIEW and C. When you're writing using pointers and handles into information residing in memory, that is automatically available everywhere. Although the typedef propagates, the data you put in is not. So let's just go quickly back to the robot main and summarize what we've talked about in this entry. There's a bit of a long discussion. We did a quick tour of the Robot Main.vi. We talked about the really key points, which are there's a begin VI, there's a teleop VI, there are clusters of data which send information around, that those clusters are all typedefs, which you can modify, that the begin VI opens references to all of the important objects that you're going to use, that those references are all available from there on in the autonomous and in the teleop mode, that there's two different types of autonomous mode, the iterative, which is more complicated, and the independent, which is just like the basic framework, that the independent autonomous mode uses a global variable to get the information from the begin VI to the autonomous mode. And we talked a little bit about how to send data around, that it's not as easy as it looks to make data available between the autonomous mode and the teleop mode. But in the grand scheme of things, that may not be such a problem, because in reality, how much information do you need to send between your autonomous mode and your teleop mode? Well, that very much depends on the complexity of the process you're trying to run on your robot. Thank you very much for watching this video. There have been several pop-ups throughout this video, which, for subscribers of the lvmastery.com online training, will drill you right into the training material relevant to that particular section. Remember that these introductory videos are intended to get your feet wet and get you introduced to LabVIEW. There's lots to learn about LabVIEW, and we're very proud of the lvmastery.com online learning experience. We've had a lot of great feedback from other FIRST team members and other high school students who have taken the training. I'd also like to mention the Buy One, Give One special offer for mentors, teachers, and parents associated with FIRST teams. We're allowing anyone who's associated with the FIRST team to purchase the LV Mastery online training for the academic price of $500 for all 3 courses. And for anyone who takes us up on that offer, we'll donate a training seat to a member of their team as well. Thank you very much for watching. This has been Ben Zimmer from lvmastery.com. Bye for now.